Today should be shorter than normal. We're talking about exponentials and logs kind of like together, just to make sure that you understand how they work together. So you've got to be able to go back and forth between exponential and logs and understand natural log, which is like log base e, and go back and forth with the log base e's. Just for a second, since I was just talking about log base e, would you please write down your closest approximation of what e is? I hope you know by now it's a decimal. It's kind of like pi. It goes on forever, never repeats. But what is e? Take a second. Don't just listen to me. Write. What do you think e is? I would have accepted 2.7. What was a little closer than that? 2.718. Very good. And if you didn't write anything, then you didn't remember what e was. About 2.7. So when you're asked to do e to the x, it really means 2.7 to the x. Okay? Because that's what e is. It's a rounding of e, but then you got to be able to know when there's a log base e, it's the same idea. That's about 3, 2.7-ish. Okay, but if it is here and here, the biggest thing from yesterday was if it has a base of e, then you're looking, if these bases are the same, then the answer is whatever the exponent is. And if there's no exponent, what is the exponent? 1. So this one would be equal to 1 because it's got the same base here. And this is always kind of its own little base because it has an exponent on it. So one way you could say it is if the base matches the argument, then the answer is the exponent. But that sounds so long to me. I'd rather just say, look for the bases to be the same. Because in a way, that's the base also. All right, so let's get back on the plan here. What's the inverse of adding? Subtracting. What is the inverse of squaring? Square root. So this was adding, was subtracting. This is square root. And by the way, square root also means to the power of 1/2. You guys get that that means the same thing, right? That means that. If you haven't made that connection yet, you got to know square root means power of 1/2. Next one, what's the inverse of cubing? That means like x to the third. What's the inverse of that? Like how do you fix that? Cube root, very good. Also known as to the power of 1/3. And what's the inverse of exponentials? Logs. That's kind of the point. Logs and exponentials are inverses of each other. All right, so let's make sure you remember what an inverse really does. Like an inverse, the x's and the y's switch around. So here's also inverses. This is your classic exponential growth right there. And inverses were a reflection across the line y equals x. And here is the inverse. So like the point 0, 1 turns into the point 1, 0. Look at that. And the point right there, which is on this one, is 2, 4. So then the other one must have the point 4, 2. Do you get the x and y's are switching around? Do you see that exponentials and logs, this is a log graph right here, they are a inverse of each other. They're inverses. So if you made a reflection, do you get how there's a reflection straight across that line? For every point, there's another point straight across the line? All right. So that's a reminder of inverses. That's something we learned in first semester. It's been a while. But inverses are a reflection across the line y equals x, and that's what exponentials and logs are. Okay. So what I taught you yesterday was things like this. And I said, I think the smart way is to change the 8 into 2 to a power, and then the answer will be the power. Mason, I know you were gone, but can you do 2 to the power makes 8?
2/3.
Correct. And so then if these are the same, the answer is that. So the answer is 3. And if you wanted to kind of check yourself, in the immortal words of Ice-T, check yourself before you wreck yourself. 2 to the 3rd is 2 to the 3rd. See how they kind of like go in a little loop? I call that the circle of logs. That to the power of that, and then it comes back to that. That'll always work on a log. This to the power of this equals that. All right, now go back over here. I just told you 2 seconds ago that square root was the same as the power of what again? 1/2. Now the bases are the same. The answer is the exponent. See, before that, the kid would understandably be a little confused because they're like the bases weren't the same and it didn't even have an exponent. But if you change this to be 3 to the 1/2 power, because you know that that's what square root means, then the bases are the same, so the answer is 1/2. Make sense? All right. Now, this is a new one. You have not seen this one till now. So, I'm going to keep saying it the way I said it. I said it the other way for a reason. The bases are the same, so the answer's already there. Would you agree this is a base? It's because it's got an exponent on it. Would you agree this is the base of the log? Would you agree that the bases are the same? Then the answer's already there. What's the answer? 11 is correct. Now, I get why you might be confused about why the answer's 11, but for right now, do you get the bases are the same? And my saying is the answer's already there. Means it must be there, and then there it is. Okay, so let me explain why the answer is 11. This one's going to be like, it's going to mess with your head a little bit, but I know some kids really want to understand why. Why is 11? Instead of just telling me, look for that number. Why is it 11? So try to help me get this across to you. Do you get that this log is in the power in the original problem? That means technically this isn't a log, this is in exponential form. You know, like normally they look like this. 5 to the x equals 20. It just happens to be that there's a log in there. See how this is exponential form? And when you have exponential form, you can rewrite it as a log. So this is exponential form. So I'm going to rewrite it as a log. Log, and then I got to figure out, well, I wonder what the base should be. Well, that's not too hard. Both of the bases are 6, so it's not too hard to figure out. It must be log base 6. And then do you remember that deal where you always go do the circle of logs? The next thing is going to be the 11. And then you come back, and that equals log base 6 of 11. Look at that. Log base 6 of 11 is equal to log base 6 of 11, isn't it? All right, so this one was an exponential. I rewrote it as a log, and it worked. So I know that what I told you before is true. This number right here was the answer. That had to be the answer, 11. That's where you put the answer. And I'm just checking it down here by doing my little circle of logs thing. Okay, so moral of the story, if the bases are the same, the answer's already there. There's going to be more of those, that's for sure, but apparently not on this page. I'm going to give you one more. E to the log base E of 5. Should be able to know the answer already. Boom, it's done. What is it?
5.
It's 5. Because the base is the same. The answer's already there. And if you wanted to understand why it's got to be 5, it's because I could rewrite this technically exponential into a log. And then what's the base? E. And then you swing around to the other side, 5, and then you swing back. It equals log base E of 5. So it's true. 5 must be the answer. Okay, now back to these guys. That is gross. But somebody in here is going to figure out that I need to make the bases be the same, and then you can. You can make that weird thing here into a 6 to a power, and once you figure that out, you'll have the answer. So, in my opinion, as we take this next test, we are going to find that the kids that are strong with weird exponents win on this test. If your exponents are weak, we gotta fix them by next week, at the end of the week. That's when we take the logs test. Exponents. All right, I think there's a cell phone out. If it goes away now, I won't have to make you put it away up on the jail. All right, George, could you tell me what this could be done as? Log base 6 of 6 to the, help me with this. I know it's tricky.
1 over 7.
All right, you're right that 1/7 is that power thing. You did that part right. But this would just be 7th root of 6, not 36. So how do you get that 36 in there? Know what I mean? Like, just this is close, because now it's got a log base 6. The bases are the same. But that would just be 6 to the 1/7. Yes?
6.
Yes. Now, how the heck are you going to square the 6? You're going to square the 6 by putting another 2 right there. And then, is that 21/7? No, they're going to multiply. So 6 to the 2/7 power. Could we be tested on something like that? Yes. Yes, you can. I know it's tricky, but we'll practice it. So let's make sure you get the final answer here is 6 to the 2/7 power. So you have to be good at fraction powers. I just said a second ago, the kids that get the A on this are the kids that can handle the weird exponent powers. So do you get this is the root part? That's the root part, because see, there's the root up there. And this part is the normal power. So that's like 6, and you square it, makes 36, and then you weird root it. And now that I'm done with that, the answer is 2/7, because it's the power. Question?
With logs, is there like horizontal shifts?
There can be horizontal and vertical changes on logs, yep. We haven't even really looked at graphing logs yet. We'll do that on a different day. I showed you the quick graph of it. I'll remind you the graph kind of looked like that. But yeah, you can stretch them and shrink them and flip them and move them and all that stuff. And a regular log would start like this. Log base 2 of x. And then if you wanted to like move it to the right, you'd put something in there. Actually, that would move it to the left 3, for example. And yeah, you can horizontally shrink them. That would be on the inside of there. Okay. So back to this. I made the bases the same. And the answer was the exponent. And the hard part was just, it wasn't hard to know this had to be a 6. Well, duh, it says 6 here. This has to be a 6. The hard part is figuring out what the fraction would be. All right. So, this stuff is hard. That's why on Monday we have a review of this stuff. And then technically today is a review of yesterday mostly. So that's like 3 days in a row of practicing this because we know this is tricky for kids. All right, that you should be able to simplify it down so the bases are the same, and then you'll be able to get the answer. I'm going to pause for a second. Let me give this a shot. Okay, so you know this has to be a 5. So the first thing you do is you go log base 5 of 5. And I know that's not equal to 5, but I can make it equal by putting the right power there. Now, just think to yourself, how do I make 5 turn into 25? That's got to be a squared. That's on top of the fraction. And now, like, if I put something down there, it would do a root to it. I don't need to do a root to it. Okay? So this could be a 1, or you could just say that the whole thing is 2. There wasn't any root needed here. 5 needed to turn into a 25, so I needed a squared. But just squared isn't enough. Effie, what's the final answer? It would be negative. 5 to the negative 2. How many of you guys had that? Raise your hand if you did. Okay, awesome. Now, if you didn't, you're not good at exponents yet, and I warned you, this is the unit that's gonna kick your butt on exponents. All right, so we gotta get good at this. We knew this had to be a 5. That was easy. It's 5 to the what would make it 1 over 25. So the first thing you think is, how do I make a 5 into a 25? Oh, that's squaring. That's easy. Had to be a 2. Then you got to get used to, I think the hardest thing for people is the 1 over. And that just means put a negative in the power if you want it to be 1 over. All right. So final answer on this one's -2. And how could I know I was right? Because watch. 5 to the -2 equals 5 to the -2. Circle of logs. All right, on this one, if it doesn't have a base, like this one here doesn't have a base, then what's the base? 10. And then this one seems pretty like obvious because, well, then log base 10 of x must be log base 10 of x. I mean, don't overthink this. It's the same exact thing on both sides. It's equals. All right. So, whenever you see the one without a base, put a base 10. And it will, from my experience, the problem pretty much then is always going to use that base as you solve the problem. It's like if the base is missing, the most important thing is to put in the base. Here's another one you're going to see, ln. Do you know what to put in for that yet? Huge. Please write this down. ln. Whenever you see it, you should put log base e. So whenever you see ln, that means log natural, you replace that with log base e. I'll give you an example of a question that could easily be on your next test. ln e to the third. And it's so confusing until you do what I said. What do you replace ln with? Log, careful of what you said. Log base e, yes. Log base e. And then all of a sudden, it becomes like obvious. What's the answer? 3. See, if you replace the ln with a log base e, you'll see that the bases are the same, and so the answer is just 3. So ln doesn't have a base, and it became all about that base. Okay, so logs that don't have a base, it's base 10. ln's, those are base e. All right. This one, it doesn't have a base. Nate, what's base? 10. I still don't have it instantly, but I know that has to be written as a 10. 10 what? If I take square root of 10, that's not the same as 100, is it? It's got to be 10 to the... 10 squared is the same as 100. You can replace 100 with a 10 squared. Then the answer must be 2. Okay, this one. Garrett, there's no base.
It would be
10. Then I rewrite it as log. Base 10 of 10. But I'm lying right now because that is not just 10.
That would be 1/5.
10 to the 1/5. That means the flip of 10. No. Yeah, that means the flip of 10.
Well, but didn't you do that for the 7 last time when it was like 7 square root? You took
I just, here's what I want to challenge you with. Isn't that equal to 1/10? No?
Because on the previous one of the
Okay,
pages.
I'm just asking you. So is this equal to this? Are they the same thing?
Yes.
Yes, they are. Good. So then what's the answer? 1/5. I know, these are confusing. They even can be confusing for me. 10 to the 1/5 is that. That's the same as 10 to the 1/5. Remember that the roots go on the bottom, just like with plants. Most plants have the root on the bottom, right? This has the root on the bottom of the fraction, and that's right there. Okay, let's go to this one. I said it would come up again. This is a nice combo of like things I've told you, you have to do. Spencer, name one thing I said about this kind of question that you have to do. Yes, so what is, I don't even see the base. I mean, that's a base, but then there's no other base. So it's 10. There's a base 10 right there. And now that you put in the base, it should become clear that, oh, the bases are the same. Answer's already there. Answer's 6. Okay. Ooh, this one. Claudia, tell me one thing that would make this better.
If you added base 10.
If you added a base 10, I agree 100%. Then, Nate, tell me something to do with this 1/1000th that would be smart. Yeah, find a way to make it so that it's a 10. Now, just do it one thing at a time. How could I get this, using a power, how could I get this to be closer to 1/1000th? Ten to the power of 10. 10 to the power of 10 actually is a 1 with 10 zeros. So you overshot a little bit there. It's not the 10th power.
I don't think that far out of
You just
All right.
cube it.
Would you agree that 10 to the third would mean 10 times 10 times 10? Do you get how that's 3 zeros? 10 times 10 times 10 has 3 zeros. So that's the right one. But is that exactly equal to 1/1000? No, got us close. Iris, can you finish it off? It needs a negative. The negative power will cause the 1/, it will cause the flip part. And cool, it's all about making powers. Like I said, the difference here for the kids that get A's on this next test are the kids that can handle weird powers. All right, so then the answer is -3. All right, on to next page. Weird ones. I have never even said this till now, and I probably should have. But obviously, we're covering it before we even ask you a question on it. The first question you'll have like this will be on today's homework. What happens when that's negative? There's no solution. So let me tell you about the rules for the base and the argument. Up until now, I was just trying to get you familiar with these things, but now I got to tell you a little bit more about the base and the argument. This has to be positive. You get that that means it can't be 0? If it's positive, 0 is not positive. 0 doesn't have a sign, in case you didn't know that. This has to be positive, so it can't be 0, and it can't be negative. And this has to be positive, which means it can't be negative and it can't be 0. But I'm making a big deal about this, otherwise I would have just said they have to be positive, because there's one more rule. The base also has this rule, and it can't be 1. You are not allowed to ever use a base 1. And that seems like this weird rule, like somebody just made that up, like, why can't the base be 1? I mean, it can be everything else, any other positive number. Why can't the base be 1? I'll show you why in a second. But for right now, do you get that negatives in either spot won't work? Not allowed to have negatives. You get that? Can't have a negative in either spot. Yes?
Are there still like no solution if it has like the ln and then
Oh, yeah. No matter what your base is, LNs are just logs. So they still have the same rule. Their base, just if you say it's ln, then I know its base is e, and that's a positive number, so that's fine. So your ln has the same rules. These have to both be positive. And your ln is even simpler because you know the base. The base is e, and that means it can't be 1. But this, why can't the base be 1? Let me explain. Log base 1 of 2. And if I was going to like try to figure this out, first of all, I said there's no answer. And it's true, there is no answer. But let me explain why there's no answer. It's impossible to do this. Because why? What if I say, I don't know what it is, so I'm going to say it equals x? Then can't you just do that circle of logs thing? Yeah. 1 to the x must equal 2. It's a trap. It feels like you could put it to a power that would make it equal 2. But have you ever tried putting 1 to a power? What's 1 to the first power? 1. What's 1 to the second power? 1. What's 1 to the third power? 1. Do you get how you could put 1 to any power? And it ends up coming out to 1? So how could you put 1 to a power and make it equal 2? You couldn't. That's why it's a bad base. Because you can put 1 to the, I don't know, you might think you can somehow make it equal to 2, but you can't. There's no way to do it. All right, so no 1s in the base. If you ever see this problem, it's a trick. There's no solution. All right, so now back to these guys. What's the answer to this? No solution. I'm okay with you saying NS for no solution. It's probably the fastest way to say it. How about this one? No solution, because I said it had to be positive. Yep. Seems like this should be like, oh, can I make this be the same? Nope. Can't have a negative there. No solution. Not allowed to have negatives in the base or the argument. Okay. And last but not least, this is the big thing I was trying to get across today, that logs, like this blue part, no, exponentials. Sorry, that's exponentials. And the red part is the logs. This was EXP, and this is log. Make it in red, Mr. Server. There you go. Exponentials and logs are inverses of each other. They undo each other, just like add and subtract undo each other. Square roots and squared undo each other. Logs and exponentials undo each other, and their x and y switch around. So if you see this has the point 1 comma 3 on it, this one would have the point 3 comma 1 on it. Okay, cool. You learned everything today. So a typical question for today can have e's in it, and let's see if you learned anything from what I was just telling you. Spencer, what's the base on this first one? Correct. So it's log base E. Then I'd really love it if this was just an E, because then the bases would be the same. Claudia, can you make that into an E?
Yeah, so it's,
E to the what?
e to the negative 1.
E to the negative would make it 1 over.
Oh, sorry, e to the 1
1/2
half.
is correct. E to the 1/2. Square roots are 1/2 power, and therefore the answer to it is 1/2. This one, but there's no base. Singer, what's the base then? Good guess, but when it's ln, that's not the base 10 kind. Okay, there we go. If it said the word log and it didn't have a base, then it would have been base 10, so you weren't far off. All I did is replace this with this, and then I copied the e to the 5th back down again, and now it becomes obvious that the bases are the same. Mason, what's the answer on this one?
5.
Correct. And last but not least, this one. The first thing I would do is switch get the base in there. It doesn't seem to have a base, Nate. What's the actual base then? Yep. This is a log base E. And then what would you do? Bases are the same, so the answer's 4. In this kind, if the bases are the same, the answer's already there. There's only one thing left, must be the 4. Okay, so you have a worksheet. It should be easy to finish before the end of the hour. Just look at the directions for the worksheet. Anybody got it downloaded already?
Yeah,
In the title, did it say anything about like which problems to do?
yeah, just odds.
Just odds? All right. So then just do the odds, and you should be able to easily finish. If you get stuck, though, please walk up and ask. That's all I got for you for today.